Hi, I'm Adolph Oliver, and this is a video clip about determinants and using determinants with what is known as Cramer's rule. Now, determinants have many different uses in mathematics. What they are is a way of being able to calculate a value from a square grid of numbers. Let's give you an example here. Determinants are normally put in vertical bars like this, and I might have -2 and 3, and let's say 4 and -1. Okay, now this is a 2 rows and 2 columns, a square grid of numbers, and they come from different places. We're going to use them for systems of equations in a moment. But now, how do you determine the value of a determinant here? What you do is you multiply together the guys on the diagonals here. Okay, so here I'm drawing lines to indicate that. But you have to add an extra sign. And there are different ways for you to remember how to do this. A little gimmick I like to use is the following. Make the sign the opposite of what the slope would be of these guidelines. For instance, this guy is sloping downward, which would be negative slope. So that's minus, but we take the opposite, so we put an extra plus. This guy sloping upward would be positive slope, but I take the opposite, I add an extra minus. Now, here's how we get the values. We multiply together guys in the arm, also including these extra signs. Take either one first, doesn't matter. Let's say I take the guy going upward. Notice there's only one minus sign in all of this. So it's going to be -12, okay, and then take the guy going downward. He also has, let's see, no, we got 2 minus signs, one here and one there. That's 2, that's a plus. 2 minus signs combined to a plus. So 2 times 1 is 2. So I got -12, including the extra sign going upward, +2, including the extra sign coming downward, and now -12 plus 2, -10. Okay, well now, Cramer worked up a way of being able to use determinants to find the answers to systems of equations. And this determinant business can also be programmed pretty easily, so that's what makes it nice. But anyway, here's what's going to happen. We're going to find 3 determinants. I'm just going to mention them to you right now. D, which is just going to be the determinant of the coefficients of the equation. And then D sub x, where we replace the x coefficients with what the equation equals on the right side of the equal sign. And the same thing with D sub y. So the 3 determinants that we're going to be solving. Simply after that, the value of x is going to be the dx determinant divided by d, and the value of y is going to be the dy determinant divided by d. One of the interesting things about determinants is if you only want to know one of the variables here, you don't have to solve for the other one. You can just home into the one you want. Well, okay, let's get a little practice here evaluating just simple determinants. And again, remember that what we're going to do is multiply together the guys on the diagonals here. But we're going to be adding an extra sign. And that sign is going to be the opposite of what the slope would be of that diagonal. So this diagonal is going downward to the right. That would be negative slope, but the opposite sign is plus. This diagonal is going upward to right. He would be positive slope. That would be a plus, but the opposite is minus. Okay, well then, just evaluate these. All right, let me go ahead and take the guy going downward first here. Figure the sign. Looks to me like there's only one minus sign here. So it's going to be negative. And then what do we have here? This is 0 times 2. Well, it's minus 0. Now, the guy going the other way here, Looks to me like there is just one sign, which is a negative, so it's going to be negative. And 4 times 2 is 8. So the value of this determinant would be negative 8. Okay, let's move down to another one here. Okay, once again, indicate your diagonals. Once you get this down, these determinants are nice to work with. Okay, the guy sloping downward would be negative, but we take the opposite, so it's plus. The guy going upward would be positive. We take the opposite, it's minus. Okay, take either one of the diagonals first. Let's say I take this one sloping down. Looks to me like there's just a single minus sign, so it's negative. And let's see, what do we got here? 5 times 6, so negative 30. Now get the other guy. How many minuses we got here? Looks like we have 2 minuses, so those combine to a plus. And 4 times 6 is 24. Well, okay, negative here wins by what? 6, so the value of this determinant is negative 6. Well, let's do one more of these, and then we'll move on to talking about Cramer's rule. Okay, here we go. Going downward, going upward. Remember, the negative slope here, the opposite is positive. The positive slope, the opposite is negative. So here we go on this one. If I take the guy going upward, looks like I got one minus sign, but 1 times 0 is 0. And the guy going downward, I don't think I see any minus signs, so positive, but 0 times 2 is 0. So the value of this determinant happens to be 0. Okay. Let's use Cramer's rule to solve this system of equations. And again, what we always want to do is have these cleaned up nice to begin with, the x's and the y's, in standard form over here. Now, I mentioned the 3 different determinants that we're going to have. Let me show you how we come up with these. The D determinant simply takes the coefficients of the x's and y's. So we'd have 4 and 1, okay, and then looks like, what do we got here? 5 and 1, okay. Now, before you do anything else, you always want to find the value of this plane D. The reason for that is if it's 0, then you don't have a good solution and you don't want to waste your time doing any more work on it. So here we go again. Let's see what we get. The 2 diagonals again. Downhill would be minus slope, so we add a plus. Uphill would be positive slope. We do the opposite. We add a minus. Okay, if I take the guy going upward first, you can take either one first. There's one minus, it looks like, so minus 5. And then the guy going downward, doesn't look like there are any minuses, so it'll be positive, and 4 times 1 is 4. Okay, the value of the D determinant is negative 1, so that means we're going to have a good solution here. Now, the next thing we do is get dx and dy. D sub x equals, now here's what you simply do. You see the x column right here? When you set the determinant up, you don't get the coefficients of the x's. What you do instead is replace them with the numbers on the right side of the equal sign. So instead of writing 4 and 5, I'm going to write 12 and 14. Now, the y guys stay the same, so they're 1 and 1. There they are. So now, let's find the D sub x determinant. Okay, once again, going downward is an extra plus, going upward is an extra minus. So let's see, I'm going to have, if I take the guy going upward first, no minuses, so it's going to be plus 12. The guy, that was the downward guy. The upward guy here, a single minus. And 1 times 14 is 14. So the D sub x equals negative 2. Okay. Now, likewise, find the d sub y. Well, you probably figured out already what we're going to do is replace the y coefficients with the guys on the right here. So the 4 and 5 for the x's remain. The y's, however, instead of writing 1 and 1, we're going to write 12 and 14. Okay, so here they are. Okay, evaluate this determinant. Okay, the guy going downward has an extra plus. The guy going upward has an extra minus. So I'll do the guy going upward first. Looks like we got a single minus. 5 times 12, yeah, that is 12. Okay, is 60. Okay. And then going downward, doesn't look like there are any minuses, so positive 4 times 14, well, let's see, that's going to be what, 56? So it looks to me like this is negative 4. Okay, well, again, remember, the main D determinant, and it's the one you find first, just take the coefficients of the x's and y's and solve it. And as long as you end up with something over here which is not 0, then continue on to find the other solutions. D sub x, you're replacing the x's with the guys on the right. D sub y, you replace the y coefficients with the guys on the right. Okay, well now, what's this going to do for us? Well, here's what it is. The x value simply equals d sub x over d. Well, what's d sub x equal? Negative 2. And what is d equal? Negative 1. So x equals 2. Okay, there's our x solution. Now, the y solution works the same way, but with the d of y. Y equals d of y divided by d. Well, we got d of y equal to negative 4. The d, of course, is negative 1. So y equals negative 4. So there we go. We got the system solution here. The x value is 2, and the y value is 4. And we used determinants to do it, but when we use determinants in this way, remember I said they can be used for lots of different things. Using the determinants like this to be able to solve a system of equations is known as Cramer's rule. Cramer, first guy that, worked out how this could be done. Okay, here's another example, but we've got to put it in standard form before we start making our determinants, because we got to make sure we get all the numbers in the correct spots. Okay, well, notice there's no x on this guy. So if I was to rewrite this with an x over here, I could put 0x, okay, and then what do we have? Minus 6y, okay, equals, what do we got here? Negative 3. Okay, the second equation is in order. We got 5x, okay, minus 6y equals negative 1. Okay, well, there we go. Now, why we line these up again is so that we can set up the different determinants that we need to make sure that they're correctly lined up. So here we go. The first determinant, d, okay, we're just going to grab the x and y coordinates. So for the x's, I got 0 and 5, and for the y's, I've got negative 6 and negative 6. Okay, remember, you always find this first determinant before you go on, because if it's 0, then you have a bad solution and you don't need to go on. Okay, the guy sloping downward to the right would have negative slope, but we do the opposite, so it's plus. The guy going upward to the right, positive slope, we do the opposite, minus. Okay, well, let's see, I'll take the diagonal going down, and there's one minus sign, so it's negative. 0 times 6, well, that's just 0. Okay, going upward, looks like we got two minuses, so that's going to be plus. 5 times 6 is 30. So looks to me like the plane D, determinant equals 30. So since this is not 0, we've got ourselves a good solution. So we want to keep working with the other guys. Okay, so here we go. Let's find D sub x. And remember now, what you do is you replace the x coefficients with what's on the right side of the equal sign. So negative 3 and negative 1, you just take them right in order. The y's stay the same, so minus 6 and minus 6. Now, as usual, we evaluate the determinant. So the guy sloping down, opposite would be plus. The guy sloping upward, opposite would be minus. Okay, so, well, let me take the guy going upward first. Notice he's got three minus signs. 1, 2, 3. 3 minus signs is negative. 1 times 6, okay, is 6. Okay. Now, take the other guy. I got two minuses. Okay, so that's positive. And 3 times 6 is 18. So it looks like D sub x is going to be positive 12, I guess, huh? There it goes. So we got the plane D, we got D sub x. Let's go ahead and get D sub y, and then we can get the answers to this. D sub y, now again, we're changing the y coefficients, not the x. So the x's stay the same, 0 and 5. Okay, and then we're going to replace the y guys with negative 3 and negative 1. Okay, here they come. Now again, our guiding bars here. Negative slope, we take the opposite, there's an extra plus. Upward slope here would be positive, we take the opposite, so there's an extra minus. Okay, let's figure out what we got. We'll do the upper guy first here. Two minuses give me a plus, so 3 times 5 is 15. Okay, going downward here, I only have one minus, so it's negative, and 0 times 1 is 0, so this is positive 15. There's our D sub y. Okay, well now we're all set to come up with the x and y values that are a solution to this system. Remember, x equals D sub x over D. Well, D sub x is 12. Okay, D we got to be 30. Okay, well, we can divide 6 into both of these to reduce it down. 6 goes twice here, 6 goes 5 here. So we get x equal to 2/5. Okay, well, let's get y. Y equals D sub y over D. Well, once again, what's the D sub y? It was 15, and the D is 30. Well, it looks to me like this just reduces to 1/2, so y equals 1/2. Okay, well, there we go. We got our values, so we can write out what the system solution is. Okay, the x value is 2/5. Okay, the y value 1/2. Well, here's one last example to look at, and it's already in standard form. Everything's lined up, so thank you very much. We can go directly to getting our first D determinant. Okay, So here we are. Remember, with the D, you just grab the coefficients of the x's and y's. So I've got -3 and -4 and -3 and -4. Okay, well now, to evaluate this, again, remember we have to add those extra signs, so the downward slope would be negative, but the opposite is positive. And we always take the opposite of the apparent slope. Upward to the right would be positive, okay, but we take the opposite slope, so an extra minus. Okay, let's see what we got. If I take the guy going upward first, I've got 1, 2, 3 minus signs, so it's negative. 3 times 4 is 12. Okay, going downward, I have just 2 minus signs, so that's positive. 3 times 4 equals 12. Oh, look what just happened. We got our D determinant to be 0. Okay, well, there's no reason to go after D sub x and D sub y. This does not have a good solution. In a 2x2 system, these guys are either parallel or on top of each other, and you could look up there and figure that out. But here's another reason why the 0 doesn't work. Remember, of course, that if you were finding x, you'd get D sub x over D. Well, if D is 0, then you're dividing by 0 and it's undefined. Okay, so that just kind of reiterates the fact that you have a bad solution. So this is why we always find the D determinant first. If it happens to be 0, okay, then we just say bad solution, which of course in effect we either have, if the lines are parallel, no solution. If they're on top of each other, infinite solutions. But anyway, you do not get a good system solution.